Welcome and thank you for listening today. My name is Tristan and my partner is Gabby. We'll be talking to you about the use of green roof systems within the modern world. So what is a green roof? A green roof is defined as a roof of a building that is covered with vegetation and media, planted over top of a layer of waterproof material. Interest in green roofs has increased over recent years, due to the potential they have to counteract many of the environmental impacts of increasing urbanization in the modern world. In this presentation, we will discuss some of the benefits associated with green roof systems, as well as several of the design concerns related to their implementation. So what are the disadvantages and advantages of green roofs? Some advantages of a green roof is that they add aesthetic appeal to the urban environment. Also, many psychological and physiological benefits can be provided by adding green roofs to our urban centers. People working in office buildings would have the opportunity to take their breaks while sitting on top of a green roof, helping to provide a calming effect. Green roofs also increase the amount of habitat available to different organisms, improving levels of biodiversity. Another advantage is that they have benefits such as mitigating the risk of flash flooding, thus helping with stormwater management. Also, green roofs reduce energy costs and help to mitigate what is called the urban heat island effect. We will talk more about these throughout the presentation. But green roofs also have disadvantages. One of these are the costs associated with green roofs. So there's two main types of green roof systems. There's extensive and intensive green roofs. First, we'll talk about intensive green roofs. Intensive green roofs typically have a deeper soil depth than extensive roofs. Soil depths of intensive roofs are greater than 6 inches typically, allowing for a wider range of plant diversity. Vegetation at larger sizes can be incorporated into intensive systems, including shrubs and trees. Intensive green roofs are designed to allow for human accessibility, making landscaping a necessary element. They will require greater levels of maintenance compared to extensive systems, largely due to the wide range of plant diversity. Along with this, intensive roofs will also depend on supplemental irrigation to support the longevity of the planted material. Although more costly, the environmental benefits of intensive roofs are greater than extensive, specifically the improvements in biodiversity and air quality. Now, extensive green roofs are comprised by a relatively shallow soil depth ranging anywhere between 3 inches to 6 inches. Extensive green roofs have great potential in the realms of stormwater management and insulation. Because of the shallow soil depth, these roofs do not support as wide a range of plant diversity when compared to intensive roofs. The trade-off is that even though there is less potential for biodiversity, there also is less maintenance requirements. Lower costs are associated with extensive systems, both in maintenance and installation. This makes their implementation much more economically feasible. Extensive roofs are typically non-irrigated. Some may incorporate irrigation systems depending on the design. Another reason extensive roofs may be preferred over intensive roofs is the reduced need for structural changes of an existing building, making them a viable option when addressing environmental concerns. Green roofs reduce the heat fluctuation through the roof. Unless energy for cooling or heated can lead to significant cost savings. Conventional roofs absorb radiation, which then raises the temperature in highly populated areas. This is known as the urban heat island effect. By improving energy efficiency and addressing this effect, we can be better prepared and adapted to climate change. The created heat can also lead to low quality air because the hotter a city gets, the more energy goes into cooling, such as air conditioning. When the building gets hot inside, it uses more air conditioning, which uses more electricity and wastes energy. It not only results in more heat being released into the air, but also contributes to air pollution as more greenhouse gas emissions are discharged. So why are green roofs important here? Scientists have been researching and have found that by using alternative surfaces and green roofs, this will lower the temperature of the air in the cities. A modeling study found that adding green roofs to 50% of the available surfaces in downtown Toronto would cool the entire city by 0.1 to 0.8 degrees Celsius. Since a green roof reduces the temperature in the surrounding area, it could in turn save billions of dollars every year in energy costs. This is true for the different seasons. In summer, the green roof protects the building from direct solar heat, and in winter, the green roof minimizes heat loss through added insulation on the roof. So one of the main benefits that we found in our research was associated with stormwater management. Green roofs can be effective in both urban and rural areas as a solution to managing stormwater drainage. Green roofs reduce the amount of stormwater runoff created from impervious rooftop surfaces. Stormwater management is one of the main benefits of a green roof. Due to excessive amounts of urban development, many hard surfaces have been added to our cities. These cannot absorb water and precipitation needs to go somewhere. So this produces the problem of runoff, and this needs management. This can put stress on city sewer systems as it can only hold so much water. If there is heavy rainfall and the sewer system is running at maximum capacity, flooding may occur. When this runoff is causing flooding, it won't become treated, so pollutants such as oil, gas, chemicals, nutrients, and sediment will stay in that runoff water, which could eventually hurt ecosystems, increasing the need for water treatment. During rain events, rain will penetrate the soil of the green roof slowly. This will help slow down the flow rate of runoff and help regulate the flow entering the sewer system, preventing it from reaching maximum capacity. Average runoff retention of the green roofs range from between 10 to 60%. That depends on the magnitude and length of rain events. Green roof systems manage stormwater before it drains off the roof, addressing the stormwater issue at the source rather than after the runoff has been collected. Now that we know some of the benefits that green roofs can provide, where do we start? First, a good design has to be created. So who's responsible for designing a green roof? Engineers, architects, and landscape architects are all involved in the design of a green roof system. Architects and engineers must consider structural requirements such as building materials, waterproofing, height restrictions, minimum slope, ventilation, grading, and drainage. Other properties that are considered in green roof construction include live, dead, and transient loads, snow loads, material density, and building codes. From this, structural engineers are able to create loading diagrams of the structure, allowing for proper size of building supports to be selected. Factors including water consumption, fertilizer usage, weight and depth of root balls, and irrigation requirements are also taken into account. Such considerations are of importance to landscape architects involved in the design. Great attention should be made when selecting the growing medium, as this is the most critical element affecting stormwater retention and runoff water quality. Depending on the objectives of a green roof, plant materials should also be selected accordingly. The type of plants used can provide varying degrees of benefits linked to biodiversity and aesthetics. It's important to select the right plant for the right location, especially when designing a green roof. And here we see an image of two construction workers laying out reservoir sheets, which are used for drainage. Alongside this image, we have a chart discussing some of the plant material used in green roof systems and the numbers associated with each. Just take a minute to look at some of the numbers to get an idea of how everything is related to one another. So here's some of our references we used in the production of this presentation, and also in the compilation of our bibliography. In summary, Installing green roofs is one option that can reduce the negative impact of urban development while providing numerous environmental, economic, and social benefits. Furthermore, the construction and the maintenance of green roofs can help supply business opportunities for roofing contractors, plant growers, landscape designers, and other green industry parties while addressing the issues of environmental stewardship. Thank you for your time and listening to our presentation. That concludes our presentation on green roof systems.